Welcome to Ask and Learn.
Okay, so this one is about two plates, and I personally love plate questions. Once you get over the non-intuitive nature of the fact that the electric field for infinite slabs is not spatially dependent, like once you get over that, I would say these problems are computationally pretty simple, or they're pretty simple all computationally always, but then they're overall very simple like once you really understand the fact that the electric field of infinite slabs is spatially independent. So if I were you, I would allocate time to understanding these. I think you'll get a good bang for your buck in most classes. Anyway, so you have these slabs and then you have these charge densities. Sigma is, so this one would be negative sigma, but yeah, sigma is 7.00 times 10 to the minus 22 coulombs per meter squared. And then this one has minus sigma, and then this one has plus sigma. Sorry about my random coloring. I don't think, maybe one day I'll get more consistent. Who knows? So anyway, okay, so you want to find the electric fields here, here, and here. And then so this one is for A. And so I'm going to talk about A in detail and then less so for B and C. So for A, you want to find the electric field, and so you want to use the superposition of the electric fields from both sheets. So the field due to the negative charges is going to point towards the negative charges. And so I can represent it this way, and then I'll just call this E negative to represent not one. Ooh. Negative. To represent the charges from the negative sheet. And then, great. And now I want to get the electric field due to the positive sheet. The electric field due to the positive sheet points away from that sheet. So over in zone A, that's to the left. I'll label that E plus. And then you might think, oh, well, E negative is closer. It's got to be bigger. Wrong. Again, the electric fields are spatially independent in this model of an infinitely large slab. So these exactly cancel, and then the resultant field is 0. The same is true for B. 0, but not C. So if you do the same thing, then you'll get a field to the left from one and another field to the left from the other. So they actually add together. And so you can get, so that the electric field due to a single one is just sigma over 2 epsilon naught. I'm sure this derivation is in your book, and if by some act of, I don't know, philosophy it's not, then it's definitely on the internet. So I will just quote it. And so the electric field is going to be, the magnitude of the electric field is going to be this. And then if you have two of these and they're contributing the same, you multiply it by 2. And so you get the even simpler formula that it's just sigma over epsilon naught because they have the same sigma. And let's think about direction. So they're both pointing to the left. So it's going to be in the negative I hat direction. And then finally, if you plug in sigma is 7 10 to the minus 22 and epsilon naught, you'll get that E is equal to, maybe you'll get, who knows what you'll really get, 7.91 times 10 to the minus 11 newtons per coulomb, in the I hat direction. negative in the negative I hat direction.